1. Hello everyone, my name is Andrew Breutman. I'm from Levotech. We are solution consultants and system integrators for the HxGN EAM system, and you just heard my colleague talking about some of the features of HxGN EAM. We are next to them, and I would like to present here some of the use cases related to linear assets when it comes to the asset management of the truck. This specific example is going to be from the Metrolinx implementation that took place from 2018 to 2023. And thank you for joining. Again, that's me, about 15 years in the HxGN EAM industry, and specifically in transit for about 6+ years. How I define myself: I was born to fish but forced to work. So that's my motto in my life. Let's continue to some business. Again, a little bit about us. As I said, we are a system integrator and business consultant, solution consulting company located in Burlington. We have clients in the asset management industry across Canada and some of the US. In addition to HxGN EAM, we also work with ERPs, in particular Infor-LN, and business intelligence solution from Infor as well. It's called Infor-Burst. Let's talk about Metrolinx story. As you know, Metrolinx, they have about 500 kilometers, or I don't know if miles maybe, of the truck across southern Ontario, going from Oshawa to Guelph, and then Niagara Falls to Barrie, even further. So the biggest challenge with Metrolinx implementation was a significant amount of linear assets in particular, because Metrolinx also have discrete assets like buses, like buildings, stations, but the main challenge was how to implement linear assets in HxGN EAM. When we talk about linear assets, we actually mention rail, ties, ballast, bridges, culverts, and all these assets that come with different classes and different attributes related to each. The complexity was also how to define the assets around the railway, which is signals, or bridges itself, or joints, because some of you can say joint is a discrete, but joint is actually linear. So there was also a challenge how to define these and implement them in HxGN EAM for the asset management and the work management. Technological challenge was that how to transition more than 100,000 assets from the field into the asset management application, and then how to integrate all these assets with ArcGIS or ESRi solution, and have it all visible on the mobile devices or the desktop applications, and have it also useful for the maintainers, how to find the assets around me and how to do the maintenance on piece of truck, or ballast, or ties, or I don't know, first mile of a bridge, or a culvert. So our solution included collecting all this information by analyzing the diagrams, or by actually physical walks on Metrolinx corridors, and collecting it all in digital format, so we could actually translate them into data and then transition into HxGN EAM. The decision we made that rails and ballast and ties are also linear assets, because this is this is the decision that was made for Metrolinx. If you look into some other implementation that we were part of, for example, MTA. So MTA decided that linear assets are actually discrete. So if you take a piece of rail and you break it in 100 feet or 100 meters, you have a million of little segments. It's another solution that can be implemented in HxGN EAM, but we suggest and recommend to use the linear referencing in HxGN EAM. The corridors that Metrolinx has, they were all set up as systems, and each system had a collection of all the linear assets and discrete assets around them. In addition to just the asset management, work management, we also implemented condition rating. So for example, you could actually see on each piece of rail or ballast or tie from mile to mile what's the condition of that asset. And the condition rating was done periodically and updated in the system. We also implemented segments and some linear offsets, so that's also available as feature in HxGN EAM. The crossings actually were something we decided to make them as discrete assets, because it was a decision made to make the maintenance easier, because the crossings don't have too much of a length, and sometimes when the linear assets are too short, it doesn't make sense to manage them as segments in HxGN EAM. At the end, all the data was integrated into ESRi system, and we made it available on maps on the desktop and mobile, allowing the maintainers to find the assets around them and perform work. And then you can see some of the examples. So the example on the left is example of how would specific routes be set up in HxGN EAM. Again, we use the linear referencing to help and implement it. You can also have different color coding available to identify easily by color different asset classes. On the right, you can also see example of different equipment or parts or points of interest around the railway. So, for example, if you would have a river going just near the railway, or you have I don't know, buildings or forestry, you can also have them all identified and put on the linear reference model. And then you can always create work orders, so you can add some conditioning, or you can do inspections on anything that is related to the linear model. You can also do different color coding. Sometimes we can do different icons as well. So the solution is robust enough to identify different assets and classes related to the truck. The challenges we had is, as I mentioned, to identify each asset class. What are they? If it's a linear asset or if it's discrete. For example, joints, they were identified as discrete, crossings as well, but let's say bridges and culverts and rail, ballast and ties, they were identified as linear assets. HxGN EAM comes with import utility that allows to import large amount of data into HxGN EAM from Excel files. So that was used to import all different segments and pieces of information that was collected and input into the HxGN EAM solution. Another challenge we had is how to identify the fences that are part of the railway envelope. So the fences, they have they have the chain. They have chain fences. They have wire fences. They have different fences around Metrolinx assets. And the decision was made to identify the fences as discrete assets. So, for example, every 100 meters or 100 yards, it was identified as a piece of fence. And then, let's say if I have 5 kilometers of fence, it can be possibly 50 different assets or 500 different assets. And it allows actually to do easier work on the fences. ESRi was also a little bit challenged because of different layers. So at the end, we implemented a layer for railway, a layer for ballast, a layer for ties, and so and so. So if someone wants to see the full ESRi model, they would have to select and present all the different layers available. But the layers were actually used to identify different asset classes. Another challenge was to actually identify and analyze the diagrams that Metrolinx has. Some of the diagrams, they were not updated, they were kind of maybe outdated. So we had to work with the railway specialists and sometimes go the walks on the railway to identify exact miles or identify exact assets around like equipment houses, signals, or switches. That was another challenge. Also, points of interest and related parts. They were phase 2 because we decided to first of all implement all the assets and then go with the points of interest, as I mentioned. Buildings, rivers, forestry, anything that's around the envelope. Inventory management of the linear parts. Everyone asks, okay, if I have a piece of rail of, 100 yards, no, not 100 yards, 500 inch, and I want to cut a piece and I want to use it for my joints, what do? Do I manage my rail as a piece? Do I manage my rail as a linear? So it was a little bit questions around how to manage the inventory related to the linear assets. Assessment and condition rating was done again with the help of external companies, because just imagine how you do assessment of 50 kilometers of railway and what's around it. Like if the ballast is good or bad, like from 1 to 5. It was also one of the challenges. Criticality rating as well. It was taken in consideration because some of the linear assets may be critical because they are close to a specific location or they must be maintained first. So criticality was also implemented as part of the solution, and HxGN EAM supports many attributes related to different asset classes. Mobile apps, with the time of the implementation, there was no real-time application available, so there was a little bit delay with the older application. It was called HxGN EAM for transit. These days, HxGN implemented a real-time application called Digital Work, and that application performs much better than the offline applications. Again, someone can argue and say you cannot use devices around the rail, so it was all in segment of safety first, and if the devices cannot be used around the rail, then they cannot be used. So once you go away, then you can start using the mobile device, but the requirement was to have the solution available on the mobile devices as well. I know maybe I was a little bit fast, but you guys have any questions about the solution or HxGN EAM or anything related to how it works with linear assets in particular?